Sonia Bailey, and today I would like to share with you the most scientific way to cut a cake. So some of you might be wondering, well, why would we talk about cake? So just to tell you a little bit, I love to bake cakes and I love to decorate them. I do them for my kids' birthdays and weddings and anniversaries, you name it. So I saw this video online and it talked about the most scientific way to cut a cake. And so I thought, well, what about the numbers behind it? So I decided to come up with my own little experiment. So I'm going to show you how they say to cut a cake. So probably all of you, when you go to cut a cake, you're going to take out like this triangular piece. So now we're going to pretend that you get to eat the cake all by yourself. So nobody else gets to eat it. So if you were to cut out that triangular piece and then put it, say, in the fridge overnight, and then when you take it out the next day, those two sides where you cut from are now hard. So you may cut those off and throw them out. So now you've wasted the cake that you get to eat all by yourself, or you just deal with the hard cake. So instead of doing it like that, I'm going to show you a better way to cut the cake. So what we're going to do is find exactly where the center is. I know, and this is like really against all normal cuts. And I'm going to take out 1 inch directly from the middle. So this is the cake that you get to eat. That's a lot. And then what we're going to do is we're going to take the cake and we're going to squish it together. So we're just going to assume that we put it in the refrigerator overnight. So if you were going to do that, what you could do is actually put a piece of rubber band around it so that the place where you cut is now going to stay fresh. Okay, so we're going to kind of pretend like we put it in the fridge. We come back the next day. Now we're going to turn the cake 90 degrees, and I'm going to make the same kind of cut. So I'm going to go ahead and find where the center is, and I'm going to cut a 1 inch slice right down the middle. And now what we're going to do is we're going to squish the cake together. And again, assuming that we're going to wait till the next day, we're going to go ahead and put that rubber band around it. We'll come back the next day. We're going to turn it 90 degrees. Now the thing that's kind of interesting is I already have one cut here, but I still want to cut out 1 inch. So I'm going to have to actually make 2 kind of cuts around that one piece. So assuming my measurements are very precise, we have exactly 1 inch. And so we're going to have to kind of cut out these 4 pieces. And then what we'll do is we'll just kind of squish the cake back together, and then that pattern would continue. So now here comes the math. So I went and did this diagram. So we're going to assume that the circle had a radius of 6 units. So I went ahead and decided to look at the volume for that circular prism. So using V equals pi r squared h, the volume for the original circular cake was 108 pi inches cubed. So then we went ahead and made that 1 inch cut. And now this is where the fascinating math comes in. So when you go ahead and squish that cake together, now you have an elliptical prism. And that's really, really cool to me. So then I went ahead and I found the volume for that. Okay, so using V equals pi ABH, our minor axis is 5.5 units, but then our major axis is still what it was before in terms of the radius of the circle at 6 units. So now we're at 99 pi inches cubed, and then here is that one sliver that was kind of taken out from the middle of the cake. So then we went ahead and we kind of squished that cake back together, and now what we get is a circular prism. So we're getting this pattern of a circle to an ellipse and back to a circle. So I went ahead and I calculated the volume, again, using the volume formula for a circular prism, and I got 90.75 pi inches cubed. So what we're noticing is that we have a pattern. So when I then kind of squish that cake back together again, Now what we have is another elliptical prism. So I went ahead, I figured out the volume, and it's now 82.5 pi inches cubed. And so we've got that right here. So now our major axis is the 5.5 units, our minor axis is the 5 units. So kind of not doing all of the actual cuts. The next one though, as we would notice, is that it's a circular prism. Okay, so the next one is the circular prism, and the volume is now 75 pi inches cubed. So I thought that that was really fascinating. We go from circular to elliptical back and forth until eventually we wouldn't be able to cut the cake anymore. So what I did is I ran some numbers. So I went ahead and looked at how long would we be able to actually make those cuts, assuming that the cake doesn't crumble. So I have this sequence in terms of the volume, and the last one would be 0.75 pi inches cubed. So I saw this sequence and thought, okay, what does that really look like? So I went to my TI Nspire and I plotted those points, and it looked like a quadratic function. But obviously it wouldn't be both sides, just the side of the quadratic that was decreasing because the volume was decreasing after each cut. So I ran the regression and got the equation and found the r squared value such that x was the cut number and then y was the volume. Okay, so those were the things that I ran. I found that to be really fascinating, and I hope that you do as well, but I wanted to leave you with a couple of questions. So what if we considered instead the circumference? And what would happen? What if instead we considered the surface area? Now this is kind of interesting to me. What if we cut the cake exactly the same way, but you had to keep the volume the same each time? Okay, that would be tricky. Okay? Or what if we looked at the residuals when we went to our calculator? Okay, what if we changed the shape of the cake? What if it was somehow a square, or we looked at a triangular cake, or even like a pentagon? Like what would happen? What is the domain and the range? And then kind of realistically, when do you think the cake would actually crumble? Okay, so those are just some things to think about and leave you with. So hopefully now you're all going to go home, you're going to make a cake or a pie, and you're going to try this yourself. Thank you very much.
Nice job.
You want